All right. What I'm going to look at today is I'm going to look at compounding interest. And so this is a follow-up to the work that we were doing on simple interest. And so I'm going to kind of reference some things that I talked about in simple interest. I'll go over points that I think are important if you need to see them again. But the basic idea of compounding interest is to answer the question, what happens if instead of getting the same amount of money every single year from my particular principal in terms of interest, I instead I add on the amount of interest that I make for a particular year and I get interest on that. So let me give you an example. So let's say, for example, I was working with simple interest. So here's our simple interest example. And in simple interest, we know that interest is going to equal principal times the rate times the time. Okay? Or if I want to look at, we'll call this PN, which we're going to call this the new principal. Okay? The new amount of money that I have in the account is going to equal, right, P naught, that's my original principal, times the rate times the time. Okay? Or excuse me, times 1 plus the rate times the time. Okay? And so basically, if I just think about a single year, my new principal PN, right, and we'll take $1,000, to say that $1,000 that we'll start with, and I'll multiply that by 1 plus, and let's say we're going to take 2%, 0.2 times the 1. Okay? Well, that's going to be 1,000 times 1.02, which ends up equaling $1,020. So that's the amount that I would have after 1 year. If I look at 2 years, okay, I'm going to take 1,000, so this is now for 2 years, 1,000 times 1 plus 0.02 times 2, and that equals 1,000 times 1.04, which is just going to be $1,040. So I made another $20. Great. If I look at it for 3 years, okay, we'll scroll down for just a second. I look at it for 3 years, I'm going to get 1,000. Okay, my new principal is going to equal 1,000 times 1 plus 0.02 times 3, and that's 1,000 times 1.06, and that's 1,060. So if I look at what I've gained every single year, year 1, I gained $20, same amount. Year 2, I'm going to gain $20 again, and year 3, I'm going to gain $20 again. Okay? Which is fine, but the truth is that it's kind of a bum deal. If you think about it, what's happened is that if I keep my money in the account, they're not actually paying me interest on everything. Instead, they're just paying me interest on my original principal. But I don't have an original principal in it anymore. After the end of 1 year, I have $1,020. At the end of 2 years, I have $1,040. So they're actually going to get the opportunity to make more money, right, on my money than what I'm getting back. So I'm actually getting a smaller and smaller and smaller interest rate relative to how much money I actually have in the bank account. So one of the ways that we deal with this is called compounding interest. Okay? And what compounding interest is it's going to actually take my new principal and make that the original principal. So like, to give you a different explanation, on the compounding interest side, what we'd see is we'd start out our principal new, right? We'll start out with the same amount and the same percentage. So we've got 0.02 is our rate, and I'll let my t equal 1 year, okay? And so PN is going to be 1,000 times 1 plus 0.02 times 1, and that's great. That's going to be 1,020. That's the same exact amount that I had before. But now I want to think to myself, well, okay, so now for year 1 to 2, okay, so here's year 1. For year 1 to 2, my principal is now 1,020. So I'm going to call it, I'm going to get my P new again, but now I'm going to have my principal be 1,020, and I'll multiply that times 1 plus 0.02 times, we're still only doing with 1 year, year 1 to year 2, but that's going to give me a new amount of money. Okay? What I'm going to get this time is I'm going to get 1,020 times 1.02, and that's $1,040.40. So I actually now have made more money than I did previously. Notice that this is 1,040. This is now 1,040 cents. $1,040.40. Then in year 3, I'm going to take my new principal, and now instead of 1,020, I'm going to use 1,040.40. So that's $1,040.40, and I'm going to add to that 1 plus 0.021. So I'm going to multiply those two together, just like my simple interest formula, but like with a new principal. So we'll try that out. And what I get now is I get $1,061.21 essentially. Now it doesn't seem like a lot of money. It seems like $1.21. That's the difference. There's your simple interest, and there is my compounding interest experiment, although we'll get into that a little bit more. But it turns out that depending upon how often I reset my principal, this number can get big really, really fast. And Einstein actually called it one of the great miracles of the universe is anything that compounds, that has what we call exponential growth, right? And we're going to represent these using exponents. But that's the idea. A compounding interest, right, takes your current principal and makes that takes the new principal and makes that the current principal, and then we just keep taking the same interest rate over and over and over again, okay, as often as we actually want to, and this ends up increasing the amount of money that we might have in an account, or increasing like what we owe to a credit card company, because this is how they work, by a much larger margin than we would otherwise. Now let's look at our compounding interest formula. So let's take a look at, we've got Pn equals P naught times 1 plus RT. That's our original formula. That's not the compounding interest formula. We're going to let t equal 1. So for right now, we're going to have it be t equals 1 year. And so what that's going to look like then is just that we're going to get P naught. We're going to, for this, our new one, for year 1, we get Pn equals P naught times 1 plus R. And there we go. Now, for the second year, we're going to get Pn, and this Pn is now our new value. Remember, we took the amount of money that I had at the end of year 1, and that became my new principal. So that's going to be Pn, and then we're going to multiply that by 1 plus R, right? We're going to use the equation, and again, we're going to utilize that t equals 1, because we're going to do this every year. So this is now, if I replace, I'm going to just replace this. I'm going to let this be P naught times 1 plus R times 1 plus R. Okay, so all I did was I plugged in P naught times 1 plus R for Pn, because that's the old number, okay? Now, I should say that if this is, just try and relax and see if you can kind of follow along with what we're doing here. I'm going to give you the equation in just a little bit so we can actually kind of follow along with that, but I wanted you to understand where it's coming from, and that's why I'm doing this. So this is now P naught, and notice that this is times 1 plus R squared. Because 1 plus R times 1 plus R is squared. That's what it means, to square something. In the third year, we're going to get Pn is going to equal, and so now this is the new amount of money that I have. It's going to be P naught times 1 plus R squared, and we'll multiply that by 1 plus R. So we get now P naught times 1 plus R cubed. Well, that's kind of cool. Now notice, this is a 1 plus R to the 1 power. This is 1 plus R squared, and this is 1 plus R cubed. Well, the cubed comes in the third year, the squared comes in the second year, and the 1 power comes in year 1. So what we can see is that we have a pattern here. And that if we write this out as year n is going to be, the Pn is going to equal P naught times 1 plus R to the n. And n is the number of years you're compounding. So how many years are you actually going to be taking this compounding interest? Now, we have a phrase for this. We say that this is compounding annually. So compounding annually means we change the principal once per year. So that's what's happening there. Okay? And as we saw, this could actually kind of increase pretty quickly depending upon how much money you're in the account, right? But if we think about this, if you compound more often, you cannot change the rate and you can actually make more money, right? Okay? Because if you kind of think about it, oh, I've got more money in the account that I'm taking a bigger percentage of each and every time. So if I increase the number of times I compound, all right, then what I'm going to get is I'm going to get more and more money inside of the account. And so that's why we have different ways of compounding. So let's take a look at those. So one is we can compound monthly. So we call this compounding, and we use that phrase compounding monthly. And when we compound monthly, what we're going to be doing is we're going to compound 12 times per year because we do it once per month. And we're going to use a value, we're going to call it big K, or we're going to call it K equals 12. And that's our monthly compounding. That's pretty common, actually. That's kind of what your credit cards do. We can also compound daily. And a daily compounding is 365 times per year. And this one, we're going to use K equals 365. Okay? If, on the other hand, we get compounding biannually, that means twice per year. And so that makes K equal to 2. And if we compound quarterly, that's 4 times per year, and we get K equals 4. So those are the values that we end up with as a result of our compounding. And those are some of the different choices. If we have different kinds of compounding, we're going to get different kinds of equations. All right? But we have a general equation for this. All right? So here's our general compounding equation. So our general compounding equation is going to end up being P sub n equals P naught times 1 plus R over K to the KT. So basically, K is the number of times compounding. So for annually, it's going to be 1. Compounding per year, Our R is going to still be our rate. T is the number of years. P naught is our initial principal. And P sub n now, we've seen this now before, P sub n, P sub big N, is going to equal our new principal, our new amount of money at the end of T years. And that's our equation. Okay? So that's what we're going to use for our equations. Now, we'll see, we're going to actually kind of do a little bit of algebra a little bit later on inside of this video, in which what we're going to do is we're going to rearrange this so that we'd figure out the amount of time that it will take for us to get a particular principal. Okay? But for right now, this is going to be our compounding interest equation, and this is going to be the one that we use. So let's take a look at a few examples. All right, so let's take a look at an example. Let's suppose that I want to find the amount of money in an account if $6,800 is deposited at 6.5% interest compounded quarterly, and if the money is compounded every 3 years. So what I'm going to do is I'm going to look at this and I'm going to say, okay, well, some interesting information. This 6,800, that's my initial principal, so that's P naught. The 6.5%, that's going to be my rate. So P naught is 6,800. R is equal to 0.065 because we want to change the percentage into a decimal. We're going to do that every single time. Okay. Then we're going to be compounding quarterly. So that means our K for our equation is going to be 4 because we're going to compound 4 times a year. Okay. And we're going to be doing this for 3 years. Okay. Actually, it's not compounded every 3 years. It's compounded for 3 years. That's what I meant to say. So T is going to end up equaling 3. what we're going to do then is we're going to put that into our equation. So our equation is Pn is equal to P naught times 1 plus R over K to the KT. So I'm going to put in my numbers. Pn, that's what I'm solving for, is equal to 6,800, because that's P naught, times 1 plus 0.065 divided by 4 to the 4 times 3. Okay? So now what I'm going to do is I'm actually going to go in and I'm going to do this problem, and I'm going to bring in my calculator. I'm going to show you what my calculator looks like as I'm working through it, because oftentimes that's one of the problems that a lot of people have, is they kind of mess up their order of operations as they're putting this into their calculators, right? So I'm going to start out, I'm going to have Pn, it's going to equal 6,800 times 1 plus, and I'm going to take that 0.065 divided by 4. Okay? And if I want, I could add it to 1, but for right now, I'm just going to write it as 0.01625. So 0.01625. And then I'm going to take this to the 12th power, and I'm going to write that up there. Next, what I'm going to do is I'm going to take 1 plus that 0.01625, right? And if you want, you obviously can just add 1 to it because it's already sitting there. And so that's going to give me this value in here. So I'm going to get, this is equal to 6,800 times 1.01625 to the 12th power step. The next thing I'm going to do is I'm going to take this number to the 12th power. So I'm going to take that, and I'm going to use this x to the y button. You'll see that it's also on your calculator. And I'm going to take it to the 12th power. So caret, we say, 12th power, and I'm going to get that number. Now the thing is that I don't actually want to write that number because it's kind of long, and it's going to be rounded. So all I'm going to do now is I'm going to just multiply by 6,800. And there it goes. I've got $8,251.17 if I round to the nearest cent. So that's $8,251.17. Okay? So that's kind of the operation that I want to go through here. This will actually, we're going to go through very much using the order of operations like you learned in maybe pre-algebra. And the reason why we want to do that is because calculators don't really know what you mean. And if you mess up the order of operations on something like this, it's going to cause you a lot of problems and a lot of tension. So, to kind of review here, what I did was I looked at this, I said, oh, I'm compounding quarterly. So I'm going to use my compounding interest formula. The quarterly tells me that the K is going to equal 4. I wrote down my interest. I wrote down my principal of $6,800. And then my time here was for 3 years. Once I did that, I plugged it into my formula, and then I went through and plugged it into my calculator. All right, let's talk about a question like this. Find the final amount of money in an account if $1,000 is deposited at 7% interest compounded weekly and the money is left for 6 years. So what we're going to do is we're going to notice some information. One, my initial principal, P naught, is $1,000. So P naught equals 1,000. My rate is 7%, so R is going to equal 0.07. Notice that it's compounded weekly, and we haven't talked about weekly, but there are 52 weeks in a year. So since there are 52 weeks in a year, K is going to equal 52. That's going to be our compounding. It's going to be 52. And T, my time, is 6 years. Now that I have my information written down, I'm going to put it into the equation. So P sub n is going to equal P naught times 1 plus K over, or excuse me, 1 plus R over K to the KT. So that means that P sub n is going to equal 1,000 times 1 plus 0.07 divided by 52 to the 52 times 6. So the first thing that I'm going to do is I'm going to multiply that 52 times 6, and that's 312. So that's going to then change this to 1,000 times 1 plus 0.07 to the 52 to the 312th power. The next thing I'm going to do, I'm going to go into my parentheses, and I'm actually going to figure out what 0.07 divided by 52 is. So I take 0.07 divided by 52. So that, and then I'm going to add 1 to it. And that's going to give me everything in the parentheses. So divide first and then add. So this is going to give me 1.001346. So this is now 1,000 times 1.001346 to the 312th power. Next up, I'm going to take this number to the 312th power because the exponents are next. So to the 312. So 1.522 or somewhere around there. We don't even need to put that in right now. We can just go and directly multiply now by the principal of $1,000. So times 1,000. And that gives me $1,521.53. And that's my answer. So it's $1,521.53. Let me go check and make sure that that's what I wrote down. There it is. So the process is exactly the same each and every time. Read your problem carefully, put in the values for your variable, put those values into the equation, and then make sure that you're following the order of operations as you're putting it into your calculator so that you can get the correct answers. All right, let's look at a different kind of problem. And this kind of problem is somewhat practical. It's a little bit basic, but it's kind of an idea that we oftentimes think about. Let's say Javier and Belinda have a new grandson. How much should they invest now so that they will have $150,000 for his college education in 18 years? The money is compounded at 5.7% daily. Now, if I think about this, what I'm looking for is how much money should I put into the account so that at the end of that time, that money plus its interest will end up being $150,000 if this is the information that we have. So in this case, right, we're still going to use the compounding interest formula, but what we're going to need, we're going to have t, my time, is going to be 18 years. My compounding, it's daily, so k is going to equal 365. My rate, r, is going to equal 0.057, and we don't know p naught. That's going to be my unknown. Instead, I know my principal at the end, which is going to be that $150,000. Okay, so that's what we have. What we're going to have to do here is we're going to have to do a little bit of algebra, but it's nothing too terrible. It's actually pretty simple once you see it. So we're going to take $150,000, and that's going to equal, so that's my principal new, is going to equal P naught, my unknown, times 1 plus 0.057 divided by 365 to the 365 times 18th power. And that's just the same exact equation. What we're going to do is we're going to figure out what this number is first. That's going to be the first thing that we go and figure it out. So the first thing I'm going to do is I'm going to multiply 365 times 18. $6,570, that's my exponent. So I get 150,000 is going to equal P naught times 1 plus 0.057 over 365 to the, what was that number again? 6,570th power. There we go. Next up, I'm now going to figure out what's going on in the middle here. So it's going to be 150,000 equals, and this will be P naught, and this is 1. We're going to go find that, so let's get our calculator. We'll get 1, excuse me, not 1, but 0.057 divided by 365 plus 1. And so that's our value right there. And we're going to raise that to the 6,570th power. So I'm going to write that in. So I get 1.000156616 to the 6,570th power. Now, I'm not actually going to use this number right here. I'm actually going to use the one in my calculator. Okay, I'm going to use the one in my calculator because it's going to be much more sensitive, and you're going to see it's going to get big fast. Like even these numbers down here, the ones that are way over on the decimal, they're going to make a difference when we take them to the 6,570th power. So that's what we're going to do, x to the y to the 6,570th power. And there it is, 2.78966. So that's my number that I get here right next to my P naught. So I got 150,000 is going to equal P naught times 2.78966, and we'll just do 0.4. Okay? Now my job, I've just got to do a little bit of algebra. I'm just going to divide out. I'm going to isolate P naught. So I'm going to take that, divide by 2.7896604 on both sides. Okay, so I'm going to take, that's going to be 150,000 divided by, and I'll just put 2.7896604, and that gives me $53,769.99, because the 5 is going to round up, and so that's how much we have to put in as principal. So P naught is going to then equal that value. That's $53,769.99. Same exact equation. We're going to do basically the same exact process. It's just that we're going to set up an equation so that at the very end we're going to have to divide through by what would essentially be our interest rate, like our rate of return, all right, which is this 2.7896604. And then that gives me my principal. So if I'm looking for the initial principal and I know my new amount of money, I can use the exact same equation. All right, so this gives us some very basic ideas of how to utilize compounding interest and how the compounding interest formula works and what we can use it for. We're going to see a little bit more of this work when we start looking at loans and how loans work. So this completes the lecture.